Okay, let's try a much harder problem. Let's do an example from physics and show you how dimensional analysis can solve problems in physics quite easily. How high can 10 joules of work lift 30 kilograms of mass against the gravity of Earth? Well, you need to know some things here. You need to know that 1 joule is a kilogram times meters squared over seconds squared. So those 10 joules is really 10 kilograms times meters squared all over seconds squared. And 30 kilograms is just 30 kg, and if you want to write that as a fraction, it's over 1 of mass against the gravity of Earth. Now, this is one of the things you have to know in physics, but not too many of them. There are some things that you're just supposed to know. You're supposed to know that the force of gravity, the acceleration due to gravity, is 9.8 meters per second squared. What does that mean? That means that every second an object that is falling travels 9.8 meters per second faster. But, okay, those are our numbers. It requires knowing what a joule is. It requires knowing the acceleration due to gravity and how high. How high, in this case, it's going to be the standard unit of distance is meters. So we say we want meters as our answer. Well, we have meters in 2 different places. So, well, let's start, I see. Here's the problem. Okay, so this is a slightly tricky problem. If we leave this one up top, to get rid of these seconds squared, the answer is we start with this one. We start with the first one, 10 kilograms meters squared per second squared. Now we want to get rid of the kilograms, we want to get rid of the second squared, and we want to get rid of one of the meters. Let's see, let's say we get rid of the kilograms first. We have kilograms up top, we want to get rid of it. We're going to need to have a kilograms down below. That's going to require flipping this one so it becomes 1 over 30 kilograms. And if it's 1 over 30 kilograms, the kilograms are going to go away. Next up, we want to get rid of these second squareds. Hey, this has second squareds, but they're down below. These are down below already. We want one up top. So we flip this one. We flip this, and we get second squared over 9.8 meters. And the beautiful thing about this is that we have second squareds up top, cancels out with the second squareds. This meter squared is really meters times meters. Let me do that in a different color. Is meters times meters. And this meters down below is going to cancel out with one of them. And now we have the only unit left is the 1 meter up top. So what do we have? We have, up top we have 10 meters all over 30 times 9.8. And what do we do with this? We say, well, that is, what is 30 times 9.8? 30 times 9.8 is 24. So this is 10 over 24 meters. And, let's just leave it as a fraction. We can divide top and bottom by 2 and get 5/12 of a meter. So not even half a meter. A joule is not that much work, or kilograms are rather heavy. 30 kilograms is what? A kilogram is 2.2 pounds, so that's more than 60 pounds. So in any case, we get an answer. We get an answer, and it's rather powerful. Now, to work with physics, you have to have some basic understanding. The physicists are just going to say joules, but you have to know that that's a kilogram meters squared per second squared, and they just assume that you know the acceleration due to gravity on Earth. That's that number, 9.8 meters per second squared, comes up all the time in physics.